Okay, so next activity is going to be a little bit different. It's a different type of intelligence. Not everybody that does well on the multiple choice wins this. And there will only be one winner. It's the first winner that figures out the three-dimensional shape of this molecule from the data given from this X-ray crystallography. This photograph up there you'll see it on your page. It's basically just a bunch of shadows. From those shadows, they were able to deduce the three-dimensional shape of this molecule and where the components of this molecule are situated. We know it's something of a ladder shape molecule according to that X-ray. We also know that it can't be more than 10 widths across. What I mean by that is if I take these 8-prong logos and put them next to each other, that's 4 and 4, that's 8. We know that it's 10 prongs across. By the way, I just changed it from nanometers to prongs, right? This is a realistic molecule. Anyway, if I add this one, now it's too wide. If I use just those two, it's too short. And so you're gonna have to figure out the way this molecule's width is gonna be 10 prongs across. Again, the 1, 2, 3, 4, 5, 6, 7, 8. 8 would be too short. A couple other things you should know is that the 8 prongs and the 4 prongs are a certain color. There should be 2 sets of colors for those. That's important to know. Each of the structures can bond only to the sides of a molecule. In other words, you're not playing with them like you normally would play Play-Dohs. They're going to be next to each other. It says here the 6-prong can only bond to any other type of building block. So these 6-prong, you see the 6 little knobs on them, right, can bond to anything else. But the 2 prongs may only bond to the 6. So again, here's these little 2 ones. It says they can only bond to the 6 molecule. And again, we know this from the X-ray information. No 8-pronged block can be closer than the 3-prong lengths away from another 8-prong. So these 8s are going to be separated from each other by a reasonable difference. And the same is going to be true for these little 4s. There's a distance between those that matters. Because it is a ladder, it will have rungs. By rungs, we mean steps. It says there'll be 2 blocks that make up the rungs or the steps of the ladder. So you may want to use an 8 and a 6, as long as that width is right, or 8 and a 4, or 6 and a 4. That's what you're going to have to figure out. As far as I know, there's only one way to get this. So as soon as you take a picture, you deduce those requirements, construct a model using the blocks that would give you an accurate representation of this molecule. Thank you.